What's today? Wednesday. Monday up and running. Let me show you the schedule page again real quick. There's going to be about a 24-hour lag on this. It's taken a little bit longer. I'm going to try to figure out how to make it not take as long as it's taking. Where's the light switch? Oh, would you mind just killing one of those front lights? Thank you. Thank you so much. That's perfect.
The other one?
The other one.
Even better.
Yeah.
So here was Monday's class, and you'll notice that right down here there's a little line and then video from class, so you guys can now start checking out. I'll get up as soon as I can after class is over. Usually what I do is as soon as you guys are done, I go up to the office, plug the camera, and start dumping the video down to the computer, which takes about an hour. And then once it's on the computer, I edit it a little bit, I clean it up a little tiny bit, and then put it on YouTube, which takes another hour, hour and a half. And by that point, I'm usually not in the office anymore. So then I have to go back and hyperlink it into the document. So it's like this 4-part process. Each of the parts takes about 5 minutes, but they're separated by 2 hours. So you see the problem. And the problem exists, and it all has to kind of, it's kind of like changing a rear main seal in a transmission. The part costs like 10 cents, but it's like $2,000 of labor to get to it. It's that kind of thing. It's a couple nods. Yeah, it's like that kind of a process. So I'm thinking within 24 hours, I can usually get stuff uploaded for you. Which is not that big of a deal, honestly. We're in no race here to learn things. I mean, there's nothing, deadlines are way out, at least a week out, if not more. So if it takes 24 hours, it takes 24 hours, and it will be up there eventually. Definitely by Friday, things will be caught up. Like you can see, I caught up with my Tuesday classes this morning. So eventually they'll let me hire staff to do this for me. I don't have to worry about it, but it's too expensive right now.
So anyway.
Say that again?
It should be a work-study job.
Hear that? You guys don't do enough. It would be a fantastic work-study job that would pay exceptionally well.
Because those are really hard to get into.
I know.
If you're in the program, you have to.
Give me time, Melissa. I have plans for this because if this works as well, it's only my second year of doing it. If it works as well as I think it will probably be valid for a work-study position. Probably 1 or 2, honestly, to be able to upload it, edit it, and also get it like accessible in a more efficient way. Right now it's just, you know, me doing everything. So this cell will have a lot more in it after today. It'll have the bit of the PowerPoint we're doing up here, plus whatever notes I can rally to put up there. It'll be at least the PowerPoint and the video, hopefully something else too. We'll see what else we use. We're also going to have an in-class quiz. We might get to it today, I think we will. That's what we're going to go outside to collect data on. So we'll be doing that in small groups, which is also good. So there's all kinds of stuff going on each day. I'll post whatever I can on the website so you can see what happened. So in case you miss for whatever reason, at least you know what's going on. And within a day, you can watch what we did. So that's kind of the point. Make sense? Yeah. Good. So this won't be just a red box with nothing else in it except quiz due for much longer. So that was your first quiz. We'll get that back to you ASAP. I do have a grader that likes to do the quizzes in this class, and she gets paid hourly, so we let her do that. She has a real quick turnaround time, and as soon as I get these back from her, I'll email you guys a progress report so you'll know how you're doing in the class, and we'll do that once a week. Once I get into a cycle with Emily, once I know what her work schedule is and when she comes in and drops off things and pick things up, and it'll work great. So, cool? Any questions you guys have before we get going? Oh, there it is. Thank you. Any questions? You guys solid? It's dark in here. Is that okay? Yeah. How's that look through the screen? Does it look pretty decent on the LCD?
Yeah.
Where's work study? I should get them a cut of the work study funds. How's it look? Good. All right. So, what I want to start talking about today, and we might get through this today. We'll see. It might take us till Monday to wrap it up. We'll see how time goes. The course Math 105 is interesting in that there's no set requirements of what is in it. If you look at the outcomes for Math 105, if you read them off that schedule page, there's a couple topics. Modeling, I think linear and quadratic modeling are in there. And then it says topics at the instructor's discretion, which may include but not be limited to. It's written by a lawyer. May include but not be limited to. Check. And the guy that taught it before me didn't do it the way I do it, and the guys that taught it before him did it completely differently too. And my friend Becky, who did it before all of them, did it completely differently. We all kind of have like our agendas that we're slanting it towards. My point of this course is to slant this towards a everyday math / probability / statistics slant. That's what I want it to be slanted towards. So everyday math, stuff that you encounter in your daily lives. combined with the ability to read the newspaper properly and adequately. So the first one isn't going to be probability statistics. It's actually going to be more of an everyday math kind of thing. As a bike commuter, I deal with this all the time. And that idea is grade. I want to talk about the mathematical idea of grade today. Grade. Not like the grade you get in class, but the idea of grade as a geometric construct. And I love this. I love starting with this one because it allows us to get in and actually analyze quite a bit of old mathematics we may have forgotten. And I'm not talking algebra. I'm not talking algebra, necessarily. We can make it algebraic if you want to. We can totally do that. I'm talking like arithmetic that may have escaped this. So how many of you have seen a sign like this around the great state of Oregon? Yes, almost all of you. Good, good. Why do they put signs like this around the great state of Oregon? So you slow down. Why? Why should we slow down? It's steep. Ah, the word steep comes in. Good. So we hear the word grade, we think of maybe the word steep. Let's get a little laundry list of what when we hear the word grade or see the word grade. I want to turn one of the sets of lights back on. I want to kind of mix and match grade. That's perfect. Thank you. Is that okay with the screen too?
Yeah,
that'll work.
Good.
Good. Slide this over here too so we can see what I'm writing. Perfect. So we hear the word steep. Good. Steep. What other words come to mind, friends?
Slope.
Slope. Love that. Slope. Steep. Do these mean the same thing? Or could they mean the same thing?
Yeah.
Right. Not necessarily, but it depends on how you define steep. How do you define slope? How would you define slope? Would you define it mathematically or some other way? Tell me your name.
Debbie.
Debbie.
Rise over run.
Mm-hmm. I like that definition. That's rise over run. Does that ring a bell?
Yeah. Oh yeah.
Rise over run, right? Does it bring back bad memories? Hopefully not. Yes. Hopefully it won't bring back too many bad memories. I want to make it kind of a more agreeable kind of thing. Yes, this definitely has something to do with that image that's right there. For sure, absolutely for sure. Good. Other great, steep, slow. Why steep? Tell me your name again too. Janelle, that's right. Why steep?
Because it could be, like this.
It could be like this.
It could be like this.
Or it could be like this.
Yeah,
So my this compared to this.
So this is a shallow.
Oh, good. Can I add that? Steep, shallow? Good. And now the reason I love both of these is because this is extraordinarily conversational, but it can also create some gray area around the definition of what steep and shallow is, if that makes sense, right? If that makes sense. Because what you call steep and what I call, it's like when I go skiing with my brother-in-law. He's an ex-Olympic time trialist, and he goes, "Oh, let's go, Bob!" I'm like, snow plowing down, 20 feet. Looks steep to me. For him, it's a warm-up run. So this gives us a quantification of how steep something is based on a number. But I like this, because these words are extraordinarily conversational. So it gives us an idea of how steep or how shallow. Good. Anything else you think of?
Angle, the depth of the
Good.
angle.
Good. Good.
Degree.
Angle, degree, like that. All kind of related. What does all this have to do with that 6% that's right there?
Letting you know the amount of or the degree of the slope.
So that 6%, 6% is a fairly common one. You see that very often, especially out like in Eastern Oregon on the,
Cabbage.
what are those passes?
Cabbage Patch Hill, or Cabbage Hill.
I don't know Cabbage Hill. I like Drinkwater Pass.
Eastern Oregon by Pendleton.
Oh, okay, gotcha, like Northeastern. I'm thinking like on 20, going straight across the state, there's a couple passes.
Oh,
That,
yeah.
I think they measure either 5% or 6%, I forget which. Cabbage Patch, this sounds about right? And there are plenty of hills in Portland that might not necessarily have these signs on them that are wickedly steep. This town's got some insane ones. I just found another one the other day. I blew my legs up trying to ride up it. It's awesome, totally awesome. I'm gonna have to turn that into a quiz for you guys too. Yeah, it's great. Anyway,
Go to Astoria.
Astoria's the same way. Oh, those coastal towns.
It's got one of the worst grades in the country. It's like-
Interesting. Do you know what it is?
I don't remember, but the street, I swear, it's like this.
Good. Oh, if you ever go back,
San
do me a favor.
Francisco has a lot of
Stand. Hold tight. Take a cell phone picture. If you ever get a chance to go back, take a cell phone picture from the side, and just even if it's not my class anymore, just email it to me if you remember to do it. Because I haven't been to Astoria yet. And if I ever get there, I'll go find the damn thing. But I love, whenever I go to these towns, I like measuring.
It's like 3rd Street, just.
Excellent.
Yeah.
I think I can beat it though. I think. Just bear with me here. Bear with me. So, So grade, steep versus shallow, I like that. It gives us a measure of how steep or shallow something is. Slope, I love this, I love this. This is how I choose to talk about grade, because it actually gives us a number to go with the actual steepness or shallowness. Angle and degree, I love this. We can almost use these interchangeably. Now the question is what that 6% is, and would you believe that's not the angle? That's not the angle. It's related to the angle, but it's not the angle in general. So what I want you to do is I want you to think about what that 6% could be while we take a little bit of a tour through Bend and beyond. So here's a road you might recognize. Might recognize, I'm assuming some of you came up to about 20 minutes ago, maybe. B-man. What is it?
College Way.
It's definitely College Way. What is the grade of College Way if you had to guess? You're gonna get, you know what the answer is?
Yeah, because I'm 95.
Oh, because I use this at 95. Very good. Tom!
3%.
3%, love it. Other guesses. It's very hard to tell from this picture because I'm taking it from the front and not the side. Extraordinarily hard. Vote for 3%. Is there a sign on it like there's a sign on Eastern Oregon? There's no sign on it.
I'd say less.
Less than 3%, maybe like 2 or 1%.
Yeah.
Yeah. Would it be 0%? What would 0% imply in your mind?
Flat.
Flat. Exactly. Keep that in the back of your mind too. Good. Believe it or not, College Way has an average rate of 6%. Believe it or not, which means College Way's angle is the same as those passes out in Eastern Oregon that have the signs on. So why do they get the signs?
Well, it's commercial.
The highway.
It's a highway, so probably by law they have to have it on there. The speed at which they're traveling, and who's traveling on that? A lot of times big truckers. And it's not so much the angle that's the problem as the weight and the velocity. Weight and velocity in science combine to create a wonderful thing that has the letter P that stands for it called momentum. You may have learned about this at some point in your life. P equals mv, mass times velocity. Momentum can be a great thing when you're mountain biking, for example, or cross-country skiing, and it can be a terrifying thing when your brakes fail going 3 miles down a 6% grade. College Way is only about a mile long-ish, maybe not even that long, and it's not 6% the whole way. It's 6% in the steepest part of it. So what I want to do is I want to make sure you guys understand what that 6% means. Let's take a pause real quick right here. I'm going to mute the screen, I think. Yes. So what we're going to do, and in this middle board, is it going to show up on that? Okay, good. We're going to draw a little side view of College Way, a cross-section, if you will, of College Way on the middle board here. And we're going to figure out what that 6% is, okay? Figure out what that 6% is. So here is, well, that's actually something you can't see. That would be if they took a grader out, knocked off the asphalt, and graded it down to horizontal. So you don't actually see that on College Way, because College Way is not flat. College Way would be up here, right? And then this would be something else you don't see. Something else you don't see. So you're actually going to travel. What is that shape? It's a triangle. Be more specific. What is it? What kind of triangle does it appear to be that I've drawn? Good! It is a right triangle. Why did I draw a right triangle? Better question. What is a right triangle?
It has one angle that equals 90 degrees.
One angle that equals 90 degrees. And that's this guy right here. That's this guy right here. That's your 90-degree angle. Let's make sure we know that. 90-degree angle. Just make sure, if you see that little square tucked in the corner, it means a 90-degree angle. Now, because it's a right triangle, we get some fun relationships that exist in right triangles. And I want to make sure that we know these phrases. What's this piece of a right triangle called? Do you remember from like high school geometry? That's the one! Hypotenuse. It's a ridiculous word. But, you know, it's what it is. It's what we're saddled with. And in general, the hypotenuse is what you're driving, walking, biking, skateboarding on. Sometimes at cross-country skiing with the wheel things those guys do in like the middle of the summer. Those don't have brakes, do they? I always wonder, I see them skiing out the Bachelor, but they gotta come back. What do they do? 22 miles downhill. I guess there's a couple little rises and runs in there. We'll do the average grade to Bachelor too. It's a great bike. Anybody know that bike ride? Bike ride to Bachelor? It's fantastic. If you're a road biker. If you're not a road biker, it'd be hellish. But it's nice. It's nice. What are these called? Technically they're called legs, but why don't we just call them something we already called them? Well, we could. Tell me your name. Aaron, I love that. We can call him A and B, and then we get to call this guy here C. Yeah. I try to avoid that. Do you know why? I love this. Aaron says call him A and B, which makes perfect sense, honestly. Why do I not... I want to get away from calling this A and B and C. Now that seems kind of cruel, because in high school you most likely learned that A squared plus B squared equals C squared. Totally. The problem with that is I see students screw up which one is A and B and C as soon as you start dealing with the formulas. Now in your first project I actually have you dealing with a formula, with A, B, and C involved. Because I want you to be able to deal with the formula, but in conversation I'd rather use something we've already called it. What have we already called those? We've called them the rise and the run. Let's just call them that. Here's the rise. And here's the run. I don't think if we call it the run, we're going to have any problem understanding where that run is. It's going to be the horizontal part. The rise is the vertical part, and the hypotenuse is the part that connects them. We could call it the rise, the run on the road. That might be even cleverer.
Rise, run, road.
Rise, run, road? Would that be too confusing?
I like it.
Rise, run, road? We'll try them both out. You guys can help me decide. I hadn't thought about that before. That might actually work just rise, run, road. Because most of the time we're going to be dealing with roads, except today we're going to be dealing with steps, which don't have a road. Yeah, we'll figure it out.
If you go clockwise, so rise, run.
Oh, and it's actually in alphabetical order, isn't it? Rise, road, run. Run, rise, road. Run, rise.
Triple R.
Triple R.
It's kind of hypnotic, actually, if you
Yeah.
say it. Nice. It's real nice. Okay, beautiful. So there's College Way, and you're driving up here. Here you are in your car, driving up. And you're driving a Buick from 1982. It's got a dent. All right. College Way is 6% average grade. I want to come back to what average grade means too. So I've told you now on College Way, the grade, let's use the black marker, it's a little bit easier to see, I think. I'm going to go with rise and run. I am going to go with that rise and run. I like that. I like this. It's a very, very simple, straightforward definition. We're already used to it. It is the rise and the run. And I've already told you it's 6%. That's what the image said, right? 6%. Where is it? Now, FYI, I did not draw this to scale at all. This picture is not drawn. College Way is nowhere near as steep as I've drawn it right here, believe it or not. It might not look, in your mind, it might feel like it should be about that steep. That's horrifically over steep. There's very few roads in Bend that are that steep. I think I found the one that is that steep a couple days ago, like I said, when I almost imploded my quadriceps. It's awesome, totally freaking rad. But where is the 6%?
It's the average
Of what?
of all of the ups and downs.
Oh, let's come back to that if we would. Tell me your name one more time.
Janelle.
Janelle, thank you. Janelle just brought up an extraordinarily important word for us, and I want to talk about average grade. Not just yet, if you don't mind. You're absolutely correct, by the way. But I want to differentiate, compare and contrast grade with average grade. But I want to come back, if you don't mind, a little pause button. We're going to pause on that for now and come back to it, because it's very important. Janelle said, on average, the grade is 6%. If you add up all the ups and downs and lefts and rights, it averages out to 6%. And she's actually correct for the most part. For the most part, the ups and downs we have to talk about and how to rectify that difference. But we're going to talk about geometry momentarily. We'll talk about that. Where's the 6%? Please tell me your name one more time.
Debbie.
Debbie, go.
Rise divided by run?
That's what it is. It's the rise divided by the run. Now 6% is a little bit annoying. It's a little bit annoying. Can we change it to a decimal?
Yeah.
Yes, or a fraction. Let's make it a fraction, actually. I think that'd be easier, because it's already a fraction here. So as a decimal, what would it be? 0.06. As a fraction, it would be... Careful, that's 60%. 60% roads, as far as I know, don't exist. If they do, well, we'll come back to that. It's 6 over 100. That's 6% as a fraction, or as a decimal. I like the 6 over 100 because that actually drives home the point of the rise to the run. So the question, again, I have one more. That's awesome. Thank you, by the way. It's perfect, 6 to 100. So what does it mean with some units? 6 what? 100 what?
Inches?
I heard feet, I heard inches.
Miles.
Who's right? I heard miles. Who's right?
It depends on
Every
the
single
distance.
person is right. If you said inches, you're correct. If you said feet, you're correct. If you said miles, you're correct. Now here's why. It has to do with geometry. It also has to do with why your cell phone works, or why your GPS on your cell phone works, but that's another story for another time. Here's a right triangle, okay? Let's call this distance here 100 somethings. What should we call it? Let's call it 100. Want to call it 100 feet? Why not? Let's call it 100 feet. 100. No, you know what? Can I call it 100 yards instead? Just to make it as a larger unit. 100 yards. And let's draw it. You know what? Let's make it in red so it jumps out. 100 yards. I mean, you could easily track out 100 yards on College Way if you could get to the horizontal part of it, which doesn't exist because it's under the asphalt, but it would be there. Okay. If that's 100 yards, that means there has to be a 6 yards somewhere. And where would that be?
Rise.
That would be the rise, yeah? That would be the rise. That would be, I can take this out, I think, the way that is now. This would be 6 yards. And you can see now why I haven't drawn up the scale. There's a D in there, isn't there? It's funny, I forgot the D in the word heads in 244 earlier today. His is the word. He's. Forgetting 2 D's. It's got to be a sign of some condition I have. But you can see why I haven't drawn up the scale, yes? Right? Because if that's 6, this can't be 100. This is steeper than 6%. If I use the word steep correctly, this would be a higher angle than. What would that? We'll come back to what it appears to be. We'll estimate the grade momentarily. Perfect. So if you were to be able to take a picture from the side of this hill, take a snapshot, and then plot out using a horizontal axis like we did right here, you would figure out that if it's 100 here and 6 here and the unit's the same, yards to yards, you can see why it would just be 6 over 10. What would happen to the units if you were to make it 6 yards over 100 yards? The units mathematically would knock each other off, yes? They would cancel each other off. You have a whole project devoted to this, FYI, your second project. In case that seems like magic, like how do you cancel a unit? You do because it's called ratio. Ratios are unitless. They're unitless. It's kind of like when you talk about relative heights of things. How high is that compared to this? Well, both of those things have a unit of measure on them, but when you're talking about how much larger one is than the other as a percentage, the units go away. It's not 3 yards higher, it's 3 times higher, if that makes sense. If it doesn't make sense, like I said, your entire second project is devoted to that case. Okay, beautiful. So there's one way of looking at it. But suppose you can't look at 100, that's football field, right, 100 yards? Suppose you can't look at 100 yards, what if you only had like this much? So suppose you only had 100 feet to look at. Your ocular only went like this, not like that. Okay, well, where would that come out to? Well, if 100 yards versus 100 feet would be what? It would be 1/3 as big, I think, right? 100 feet versus 100 yards, because 100 yards, 300 feet. So where would that be-ish? Right about here-ish? Yeah? Okay. Is that decent enough estimate?
Yeah.
Tell me where to stop, tell me where to stop.
Stop.
Yeah, good, okay. 100 feet. That's what that distance would be there, yes? Well, if the grade is 6%, then where's the 6? There's 100, yes? So where's the 6?
Right.
Say that again, tell me your name.
Jacob.
Jacob, go!
Rise.
The rise, where is it?
Right at the end of 100.
Draw it in, yes?
Yes.
Draw a perpendicular up from the end of that 100. Here's 0-ish, you're going to call it 0. Draw a 100, or excuse me, draw a vertical, draw a perpendicular up. I'll throw another perpendicular on there. Just like that. Yeah. And how big is that going to be?
6.
6 feet. And you can see what happens if that's the only snapshot you have. You wouldn't have the big red snapshot at all, would you? You only have the small blue snapshot. But the ratio of 6 feet to 100 feet is the same as the ratio of 6 yards to 100 yards. It's 6 to 100. The units don't matter. They're like points on, damn, screwed it up. Whose line is it anyway? They don't matter at all, because they cancel. They cancel. All right? So 6 yards to 100 yards is the same as 6 feet to 100 feet, which is the same as 6 anythings to 100 anythings. I mean, honestly, it could be 6 inches or 6 millimeters to, I mean, you can bring this triangle in as close as you want it to be. It might only be 100 millimeters. This is horribly not to scale. Which means this vertical right here would be 6 millimeters. And the unit is irrelevant. The unit is irrelevant because the ratio of the sides is all the same. Tell me what's on your mind and tell me your name. In reverse order. Tell me your name first.
Tori.
Tori, what's on your mind?
Nothing.
Oh. I saw your head caught in the eye squinted. I'm like, awesome.
Your box is in the wrong spot.
Oh, is it?
90 degree.
Is it?
Yeah.
I'm going to be a geometry snob on you now.
It's not, why is it not in the wrong spot? Because
Here's-
it's on the
here's-
outside of the triangle, so isn't it wrong?
But doesn't it, okay, I like your definition of wrong. By your definition of wrong, yes it is. By my mathematical definition, it's fine, because if there's a 90 here, what does that imply about the one in here? Because the entire straight angle is 180 degrees. So if I put 90 out here, by definition I have 90 inside. So we have different definitions of right and wrong. That's totally fine. We can coexist in peace. Please, Natasha.
That side of it is 90, not the other side?
They're both 90. I'm saying it doesn't matter where I put the indicator. If I put the 90 here, it implies this one's 90. Just like if I was to extend this side out, it would mean this was 90 on this side. And this one's 90 on this side. You don't have to put the rectangle where the 90 is, as long as it forces the 90 somewhere. We can get along, right? Potato, potato. Yes. Natasha, is that okay? You buying that? Okay, good. So really, it doesn't matter what unit you use, as long as you're consistent. What you don't want to do is mix and match units. You don't want to do 6 inches over 12 feet, because then you get a skewed version of what the steepness actually is. So 6 yards to 100 yards, 6 feet to 100 feet, whatever, 6 anythings. Okay, that is the worst writing I've done in a long time. Anythings to 100 anythings. As long as you're consistent, as long as anything stays the same top and bottom, 6 to 100 is what we're going to use. 6 to 100, 3 to 50, whatever you want to call it, 0.06. Fair enough? Fair enough-ish. Good. Decent. Okay. Now, can we see all that in the camera? Can we see the entire shebang? Thank you guys, appreciate it. 2 more cents. All right.
2 more cents.
We're studying in. I run a bag of pennies somewhere. Now, what apparent grade did I make this? Let's approximate. I drew it horribly not to scale, yeah? If I asked you to approximate that grade, what would you approximate? I hear a vote for 45%. I love that. How'd you do it? Janelle, right? Yes, there we go. I asked you 5 times right.
Visually, it looks about half of 90.
Oh, careful! Oh, careful. Careful with the angle versus the slope. We're not even talking, I haven't asked you guys what that angle is yet. And the angle directly tied to 6% is not directly tied. There's another relationship that's goofy we're going to get to momentarily. We'll get into that, I promise. I promise. What's the apparent slope of this College Way line that I've drawn here? 6%. Well, that's what it is, but I didn't draw it at 6%. But now, what I'm asking you to do is ignore all these. I call this 100 yards. It's not 100 yards, right? It's not. It's some distance that I sketched out. And then I drew this arbitrary vertical line right here. What I want you to do is ignore the 6 and the 100 temporarily and try to figure out what steepness it actually appears to be. Mike, what are you thinking?
Like 30%?
How are you getting 30%? I love it.
I just visualized the rise, and I just tried to figure out how many rises would fit in the run.
You see, check that out. He figured out how big the rise was-ish, and then figured out how many rises would fit in the run. So if we call this, if you will, something, call it X, call it anything, and then like rotate it down. There's one there. There's one there. We'll call that 3. Why not?
33.
So it's about 33%, about a 1/3 slope, because the rise is 1 and there are 3 rises in the run. So it's 1 to 3. That's how I actually drew it, a 33% grade. That is ridiculously steep. College Way is nowhere near that steep, even the steepest part. Even the College Loop roads aren't that steep on campus. Although, be careful. I've noticed driving around them with the cinders down can be very, very, very dangerous. Be careful. On my bike, I'm sliding left and right all over the place now that there's no snow left. So that's what I was trying to get at. That's the kind of thing you have to do when you're out trying to estimate grade on things. You have to look at it and go, okay, this is 1. And the reason I bring this up is, how often have you been like in the woods hiking around with friends? And like, how big's that tree, I wonder? Those kinds of things. Like, how big is that tree? Well, you can use this to figure that kind of stuff out. Imagine, here's you standing looking at a tree. And that's the tree that you're trying to figure out how big it is, yeah? Right? What could you use right here to help you figure out how big the tree is? You could use your thumb, actually, believe it or not. Hold your thumb out like this. And back up until the entire tree is covered by your thumb. So make sure that your arm's pretty much in a straight line, right? And then fill the tree with your thumb like this. Send your buddy out to the tree to walk out until you see him at the end of your thumb, and then have him pace himself back to the tree. And that's how tall the tree is. If he knows his pace at that point.
That's how many feet.
That's how many, yeah, if he knows his pace or her pace, then they can figure out how big the tree is, because the distance your thumb fell is going to be proportionate to how big the tree fell. Because what you're looking at here are actually called similar triangles. They all have the same angles. We'll get to that momentarily, I promise. So this little triangle right here, this little one with the millimeters, is similar to this one with the feet, is similar, sure, to this one with the yards. Now clearly they're not the same size. They get bigger. But there is some stuff that is the same. One thing we already figured out, yeah? We already figured out they're the same because they have the same ratio of side lengths. Rise to run, rise to run, rise to run. How else are they the same? What else do they have? Exactly the same angles. They all have right angles, as we've already noticed. And you notice how they all have the same tip? I didn't draw it very well because my drawing is a little sloppy. But they all have the same tip angle up here? Well, if that angle is the same in every single one, and the right angle is the same in every single one, the last one that's behind, this one, and that one have to be the same too, because they have to add up to that same 180-degree wondrousness that you might remember from back in the day. That make sense? So speaking of angles, let's go back to 6% now. I fear I may have derailed you guys by making you approximate the actual grade that I drew. Sorry, namaste. What angle is that? If it were actually 6%. Now this is clearly larger than it should be, visually larger. If I was actually drawing, you know what the hell, let's redraw it. Let's make it look right. Let's make this right. No, let's leave one of these. Let's leave that at 100 yards. Sorry, little car. 100 feet, be gone. Okay. If that's 100 yards, let's try to figure out what 6 feet would look, or 6 yards would look like, yeah? So there's 50, 25, 12 and a half. We'll call that 6. How's that? Yeah. There's College Way.
That looks more like it.
Happy Melissa. On the inside. There we go. There we go. We got our College Way. We got our car. Now my question is, or skateboarder you ran over. My question now is, what is that angle? What angle is formed right there? I want to take 5 now. We're up at 11 o'clock, okay? And you're starting to get that glazed look. And that could be my bad jokes, that could be the poor picture, I don't know what it is. Take 5, walk around, get some air, get some water, yes? Come back in and let's figure out how to figure out what that angle is right there. Because that is interesting, I want to talk about it. Take 5, let's wander. Let's wander.